Hi everyone. In this video, we are going to look at questions involving angle properties of parallel lines and how to present our answer for such questions. You may refer to page 43 and 44 of your notes as we go through these questions and take down the solutions. Let us now look at example 1, where the question wants us to find angles A and B. This question, the two lines given are parallel, therefore we will be able to make use of our angle properties as well. Now let us look at how we can find angle A. Now to find angle A, we can see that since these two lines are straight lines, we actually do not even need to use parallel lines properties. The two angles here are vertically opposite angles, and therefore these two angles will be equal. So we can just present our answer as angle A is 130, and in brackets we state the reason, vertically opposite angles. Next, let us look at angle B. Now for angle B, we can see that since these two lines are parallel, the two interior angles here will add up to 180 degrees. So how can we present our work? Since the two angles add up to 180, to find B, I can take 180 minus 130. And in bracket at this line, we write down the reason why we can do this. It's due to the interior angles of parallel lines property. Therefore, angle B is 50 degrees. Now, let us go on to example 2 on page 44. Now, in this question, the lines AB and CD are parallel, and you will see that there are actually two transversals in this diagram. PQ and RS both cut the parallel lines. So there will be a few sets of angles which we can find using these two sets of transversals. So before we do the questions, let us see which angles we can find. So some of the deductions we can make, for example, would be, can you see that if these two lines are parallel, these two angles will be equal? Can you see also that using corresponding angles, these two angles will be equal? Next, using interior angles, these two angles would add up to 180 degrees. So before you do the question, you may want to have an idea of which angles you can find based on the two parallel lines and the transversal. So based on what we have gone through, we will see that in order to find angle X, what will be helpful is the use of corresponding angles properties. So angle X will be 74 degrees because of the corresponding angles properties. So the reason would be corresponding angles where the lines AB and CD are parallel. Next, we are going to find angles Y and Z. Now let us take a look at the other transversal that's given, because angle Y is actually touching the other transversal RS. So let us focus on RS now. Which angles will we be able to find, or what are the deductions we can make based on the transversal RS? So for example, alternate angles. If I knew this angle, I'll be able to find angle Y. Alternatively, interior angles. If I knew this angle, I'll be able to find angle Y, since the two angles would add up to 180 degrees. Another possibility, if I knew this angle, these two angles will be the same due to corresponding angle properties. So you can see that these are some of the ways that will help us to find angle Y. But however, out of these three angles, none of them are given. So in order to find Y, we will need to find one of these angles first, which can be easily done because this angle is given as 80 degrees. So by using adjacent angles on a straight line, we can find this. Or using adjacent angles on a straight line, we can find this angle. Alternatively, using vertical angle properties, we could even find this angle. So since this angle is not labeled, I'm going to first label the angle. So I'm going to attempt to find this angle. So I'm going to call this angle A, so that in my presentation, I can make reference to this angle. So due to vertically opposite angles, we can see the angle A must be 80 degrees. So I have written down my reason as vertically opposite angles. Now we can see that angle A and Y would add up to 180 degrees. Therefore, to find Y, I take 180 minus 80. And this will give me angle Y. And the reason being interior angles of the parallel lines AB and CD. Next, to find angle Z. Now, to find angle Z, again, we can look through which are the properties that will be helpful. For example, if I were to look at corresponding angles, I can find Z since Z and A will be the same. Okay, alternatively, I can also use angles on a straight line. Because this is a straight line, these two angles would add up to 180 degrees. So you can use any one of these methods to find angle Z. So here I'm using corresponding angles because the two angles here will be equal. Therefore, angle Z would be 180 degrees due to the corresponding angles property. Next, let us look at example 2b. For example 2b, the lines AB and CD are parallel. We are supposed to find the values of H and K. Now, before you look at the rest of the video, you may want to pause to try the question first before looking at the solutions. Now, let us look at how we can do question 2b. Now, for question 2b, you will notice again there are actually two transversals. The line AE is a transversal. It cuts the two parallel lines AB and CD. The line AF is also a transversal. So let us first focus on the transversal AE. What can we conclude using the transversal AE? For example, corresponding angles. These two angles must be equal. Next, alternate angles. If I use alternate angle property, this angle and this angle will be equal. Okay, you'll be able to see that there's a Z we can form. So these two angles will be equal. Okay, so of course we can also conclude interior angles. This angle and this angle will add up to 180 degrees. So you need to have roughly an idea of which deductions we can make using the parallel lines. So you will see that in the deductions we have made, what would be useful for solving for H will be corresponding angles. The angle 2H plus 30 will be equal to 69. How do we know this? Because of the corresponding angles properties where the lines AB and CD are parallel. Now 2H plus 30 is 69, so we can solve this equation to find H. So in order to do that, we subtract 30 on both sides. So 2H is equals to 39. Next, we can find H by dividing 2 on both sides. So that gives us 19.5. Next, let us look at finding angle K. Now, to find angle K, you will notice that the angle K is actually touching the transversal AF. So now we change our focus to the line AF. So you can see that using the transversal AF, these two angles are corresponding angles. Therefore, K will be equal to 2H. We have found H to be 19.5. So K would be 2 times of 19.5, which is 39 degrees. Now, why were we able to conclude 2H is equals to K? Because of the corresponding angles properties. Next, let us look at example 2C. Now, for this question, again, you may want to pause the video and try the question on your own before looking at the solution. Now, let us look at how to find the reflex angle BDF in this diagram. Now, the question tells us that AC and EG are parallel. So what we will do is to look for a transversal. A transversal is a line that will cut the two parallel lines. Can you see that there is no line here that cuts the line AC and EG? The line BD only cuts AC. the line DF only cuts EG. So we don't have a transversal that cuts both the parallel lines in this case. Now that is going to make things a bit more difficult, because that means we will not be able to make a conclusion about the angle BDF. So how can we go about questions like this? Now, a useful strategy is actually for us to draw additional lines on the diagram in order to make use of the parallel lines properties. So how do we decide where these lines should be drawn? Now the question wants us to find the reflex angle BDF. A quick recap: reflex angle refers to angles between 180 to 360 degrees. So in order to find this angle must be touching a transversal. So what we can do is to draw a transversal here. So by drawing, I'm not drawing a transversal, I'm drawing another parallel line such that the line BD is actually now a transversal. The line DF is now a transversal. Can you see that? Now I've drawn another parallel line. So I will actually be able to make use of some parallel lines properties. So how can we go about from here? Since now we have the two parallel lines, let me call this parallel line maybe XY. Can you see that because AC and XY are parallel, I can make conclusions such as alternate angles will mean these two angles are equal, which means to say this angle here is 155.5. Similarly, if I look at the parallel lines EG and XY, you can see that this angle and this angle will be the same. So this means I can find the little angle here would be 126.7. Just now this was 155.5. And BDF is basically just the sum of these two angles. So how can we present our work? First, we concluded angle BDY was 155.5 due to alternate angles where the lines AB and XY are parallel. Next, we concluded that the angle FDY is 126.7, also due to alternate angles, but this time the lines which are parallel are EG and XY. This will allow us to find angle BDF, which is a sum of the two angles that we have found earlier. Therefore, this would be 282.2. So you will see that for all the questions we have done, anytime we make use of the properties, the angle properties, in this case, the angle properties of parallel lines, we will need to state the reason clearly at the working corresponding to that property.